In this last learning target that's part of our Unit 2, we're going to be talking about something called focal length. Focal length and even focusing distance can really change how a photo looks. And this has to do with the optics that we're taking our picture through on our camera. So whether those are wide-angle optics, it's like a wide-angle lens or telephoto, or even optics on the camera that allow us to focus really closely to an object. So we're getting into a macro mode view. Our first topic is something called focal length. Another way to think about focal length is just lens zoom. We may know that term a little bit easier because it's easy for us to understand zoom. Zoom is how close in you can get to something. I want to make a connection here between the millimeter numbers that you'd see on a lens and how that results in a different look in a picture. So you'll see on the left-hand side here, this image shows 16 millimeters. That's the focal length that was used to take the picture. As we increase the focal length number, so here's 24 and then 28, you'll see that the image gets closer in towards our scene. So the lower the number that you have for your focal length, the more of the scene that you're going to be getting. And that fits into something called the angle of view that you're using with a certain focal length. Angle of view is when we're thinking about the full situation of what we could see. If we had an unlimited angle of view, we'd be able to see 360 degrees. So sometimes a photographer may put together a panoramic view of a scene where they turn the camera and they're taking multiple pictures that they stitch together to achieve a 360 degree view. But for the most part, we're going to be taking a picture through a lens that's going to show a certain angle of view. In this example, we're getting just a slice of the scene at 46 degrees based on the type of lens that we're using. Even our own eyes have a certain angle of view. So when we're looking straight ahead, we may be able to see 180 degrees if we can see kind of off to the edges of our vision, and that would be a real wide angle of view. Most lenses are more narrowed in terms of their angle of view. So let's talk about wide-angle lenses first. These are lenses that are less than 50 millimeters in their focal length. And this all assumes that we're using a full-frame sensor on our camera. So less than 50 millimeters is going to be wide-angle. The lower the number, the more of the scene we're going to see. So the three basic attributes that we're going to start to see more of as we get more wide angle is a longer depth of field, an increased angle of view, and exaggerated proportions. So we'll talk about each of these. Within a picture that's a real wide angle, we're going to start to see more of the scene. Well, one of the things that happens with the optics in a lens as we're including more of the scene is that we naturally start to have more of that scene in focus. It's creating a longer depth of field. Remember, depth of field is the amount that's in focus at different distances from the camera as we're taking the picture. If we have a longer depth of field, we'll have something close to the camera that's probably in focus, and things that are really far away also in focus. If you really want to exaggerate how crisp an image is when you're doing a wide-angle picture, for example, a landscape or a cityscape, it's best to use a smaller aperture opening to take a picture that even has more in focus. That's just if you want to have that longer depth of field exaggerated. So remember, a small aperture opening is if we use a higher f number on the camera. This is why you might even see some photographers that are doing landscape photography using a tripod even if it's in midday. They could be trying to create a really crisp image where they need to stabilize the camera because of the f number that they're using, a really high f-stop. so high aperture number, which results in a much slower shutter speed if they're trying to keep the ISO low. Dynamic range is also something that is affected by our pictures with the type of ISO that we're using. So usually it's best to use a really low ISO when we're doing a landscape wide-angle picture. With wider angle pictures, we're going to have a lot more light that could be included, different variations of light, some areas that might be bright, some areas that might be dark. So it's best to use a lower ISO to try to capture more of that dynamic range that's present within the scene. Here's just another image showing the focal length and the degrees that might appear for that. So at 35 millimeters, which is lower than 50 millimeters, we're creating an image that has a 63-degree angle of view. The next thing I want to talk about is with the wide-angle lens, how we have exaggerated proportions. So proportion is how lifelike something is in our frame. Things can either look in proportion if they look lifelike, like the way our eyes see, or out of proportion if they're being warped in some way. So with a wide-angle lens, we tend to exaggerate proportions and make things a little bit more stretched in the frame. Especially when we get to the corners of the frame, those things get stretched more and more. There's a simulator that we can open up that will help to show how exaggerated proportions change based on the type of focal length that we're using. So here it is. If we go for a wider angle of view, things tend to get warped more. So all the way on the right hand side here, you can see that yellow triangle is showing the angle of view. Things really start to get warped in this sculpture as it's being photographed. So here's a telephoto perspective on that sculpture, and then we're getting more and more wide our angle of view, and it gets more and more warped, especially if you can see that forehead getting warped. Anything towards the edge of the frame really gets stretched. Usually for portraits, you'd be using a telephoto lens because you don't want to warp somebody's face. One of the considerations that we'll have to think about when we're using a wide-angle lens is something called converging verticals. Those are vertical lines, so the lines that go up and down in the frame, that go towards a vanishing point based on how we angle the camera. Converging verticals are a great way to have somebody's eyes move in the picture. So if you want to direct somebody's attention a certain way, you can use converging verticals to do that. Like in this image, we have these lines that are heading straight up towards a vanishing point above the frame. Our eyes naturally begin to move up in the picture, up and out. Now, if you don't want somebody's eyes to have that movement occur, it's helpful to know how to avoid converging verticals. So the only way that you can avoid converging verticals is to point the camera so that the horizon line is level within the frame. So imagine that this is a view through our frame, and we have our horizon line right in the middle. Those lines, instead of going up towards a vanishing point or down towards a vanishing point, are going to be straight up and down, making it so that somebody's eyes will move not up and out of the picture, but they'll stay and linger within the frame. This is especially important when we're doing a wide-angle picture because we're going to have a lot more converging verticals appear. It's a lot easier to see those when you're doing a wide-angle picture. There is a link on the slide if you'd like to view a simulator for that as well. So which has converging verticals out of these two pictures? If you're looking at it, you're going to want to notice those lines that go straight up and down within the frame and how those lines look. Well, in this picture, all the lines that go up and down within the frame are going towards a vanishing point that actually appears right here because of the way that the camera is pointed up in the frame. Whereas this image, the camera is straight up towards our subject and the horizon line is right in the middle. Those vertical lines will just go straight up and down. Our next topic is something called telephoto focal lengths. So these are for lenses that are greater than 50 millimeters. Once you hit that 50 millimeter mark and you start going higher and higher, you're going to have more of these attributes start to appear within the frame. So the higher the number that you go, the more zoomed in you are, and the more narrow that angle of view is. It's going to isolate things. It's going to make it so that you just notice those few things that you've zoomed in on within the frame. So these are the three attributes that we'll be talking about: a short depth of field, a decreased angle of view, and compressed space. To begin with, we'll talk about how a short depth of field occurs. This naturally starts to happen the more you zoom in. You're going to take a focus on something, and the areas that are behind that focusing point, the more that you zoom in, the more blurred they become. Like the background in this image, the camera was zoomed in on these plants, and that sky behind really gets blurred out. If you'd like to really isolate your subject, sometimes it's best to use a larger aperture opening because you're going to blur the background even more. This also helps out when you want to let more light in to the picture to help out with having a faster shutter speed to avoid camera shake, and we'll talk about that later. Here's an image example of a focal length of 100 millimeters. In the previous example where we were looking at a film camera picture example here, we were at 35 and it had a totally different angle of view, much wider angle of view. So the longer the focal length, the more narrow that angle becomes, the more narrow that little slice of the pie out of the 360 degrees that we could have that you'll end up seeing. The next thing we're going to talk about is something called compressed space. Telephoto lenses make the distance between objects appear closer than they really are, and that's something that's called compressed space. Like in this picture example, we have the front of the railing here that looks like it's pretty close to the back of the railing, even though we know that they're quite far apart. The front of the train compared to the back of the train. There's a simulator that you can click on to see this as well, but I have a little example that I'll show you right here. This is before a photo session where I was meeting up with a family to do some pictures. I tried to keep gold in the same spot within the frame using my focusing guide points in the camera. I changed my focal length with each picture. I started wide and I zoomed in more and more, and then I backed up as I was taking the pictures. So at 16 millimeters, you can see the trees look quite small behind the gold. As I go to 35 and 50 and 70 and then all the way to 200, those trees look much, much closer. You're also going to notice that the background gets more and more blurred the more that the camera got zoomed in. So using a different type of focal length can really change how the background relates with your subject and how you really begin to see how things get warped or not warped in your picture. One of the other setting suggestions that I have for you when you're using a telephoto lens is to increase your shutter speed. Make it faster so that way you avoid camera shake. You'll only see more of that camera shake and have it be more dramatic when you're zooming in on the picture. So let's talk about focusing distance a little bit. This has to do with the distance that you are from your subject and how close you're getting to that subject when you're taking your picture. So you're going to dramatically impact depth of field, and this is one of the biggest ways that you're going to impact your depth of field based on how close you are to what you're taking a picture of. So the closer the distance that you are, the shorter the depth of field, and that becomes macro. If you're further away from something when you're taking a picture, you're going to have a longer depth of field. So here's 3 picture examples that were all photographed at f1.4. In this image, you're focused on the front tree, and you can see the dramatic effects with depth of field, very short. Here we're focused on the middle tree. The background is still blurred, especially if you're seeing the background trees in here. And then this is focusing on that further tree, so the third tree in this little line. There's still some blur going on in the background. You're not going to totally get rid of it at f1.4, but it's showing that you can have the background be a little bit more unfocused if you're focusing at a further distance from the camera. So lastly, we're going to talk about macro photography. So macro photography is using a lens where you can get really close to your subject to take a picture. The benefits of doing this is that you can really get a dramatic depth of field that's very short. Really helps to kind of isolate something in, but it also gives you a little bit of a different view of something that maybe we wouldn't normally see because our eyes can't necessarily focus too close to a subject. Whereas a camera, we can have a lens on there that allows us to focus in really closely. So usually we're going to be within 12 inches or closer, unless you've got a really telephoto macro lens. And you're going to see these two things really show up in the picture. So our subject is going to fill the frame. It's going to really be large in the frame, and we're going to have an extremely short depth of field. Why do we want to use macro photography? Well, again, it allows you to see something in a different way. Cameras can focus closer than our eyes, and depending on the type of lens that we're using. And that short depth of field generally has a real desirable look. It's something that really helps to just make a picture a little bit more interesting to us. Here's some different setups that photographers are using when they're doing macro pictures. One of your biggest considerations is getting a good focus, while at the same time not having lighting look strange in your picture. So you might have some issues with creating a shadow on your subject, which is why in these examples the photographers have lights that are coming from the side or even right on the front of the lens. So using a real high intensity light, so really bright light, while at the same time having that light come from the side rather than from the same direction as your camera is going to be a great way to avoid that. So be aware where the light is coming from. You don't want to cast your shadow on your subject. Sometimes using an added light for your picture is going to help out, so that way you can really have the lighting look nice. And then after you get a focus, you don't want to move the camera, because if you move the camera at all, that focusing plane is going to shift and you won't have what you want in focus. You might even switch over to manual focus, because then you can be real intentional about not having the focus change after you've got the focus. Here's just a good slide that kind of breaks everything down, so that way you can see suggested settings of wide angle versus telephoto, and even that millimeter breakdown. So 50 millimeters is considered a normal lens, not wide or telephoto. And then if you go higher, you go towards telephoto. If you go lower, you go towards wide angle.